Hello, welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. Today is the last class of the classical mechanics syllabus from the CSIR. Already I told you CSIR core syllabus, all the topics I covered up to the special theory of relativity. After finishing that, I started the advanced CSIR classical mechanics syllabus. That advanced CSIR classical mechanics syllabus, this is the last topic. That topic is Jacobi, Hamilton-Jacobi theorem. From the Hamilton-Jacobi theorem, how the questions pattern they ask for you. In this video, we have to discuss the Hamilton-Jacobi theorem. This is the last topic in the classical mechanics. After this, I won't teach in the classical mechanics in the YouTube. Now, tomorrow onwards, I have to start with the one more important paper, that is the third paper of the CSIR, that is electromagnetic theory. From each and every word of your CSIR syllabus, one topic I have to upload in our YouTube channel. So listen and estimate my teaching style. If you like, so you like my channel, share to your friends and subscribe my channel. Not only subscribe the YouTube channel, you download my app. After downloading my app, you go through all the courses. So if you really likes my teaching, you purchase the course also. That course is very useful to you. Clear? Now you able to see Hamilton-Jacobi equation. What is the Hamilton-Jacobi equation? TSSET 2017 they are asking. Now option A you have to see Hamiltonian is a function of qk dou s by dou qk comma t plus dou s by dou t is equal to 0. Hamiltonian is a function of qk dou s by dou t comma t minus dou s by dou t is equal to 0. The C is equal to Hamiltonian is a function of qk dou s by dou pk comma t minus dou s by dou t is equal to 0. So therefore Hamiltonian is a function of qk comma dou s by dou pk and so comma t plus dou s by dou t is equal to 0. Among the options, so which option is correct? What is the Hamiltonian-Jacobi equation they are asking. Now you listen the class. So what is the how we have to apply this Hamiltonian-Jacobi equation? We know that. So what you know? Hamiltonian is a function of what? Hamiltonian is the function of q comma p comma t. It is a Hamiltonian is a function of q comma p comma t. Suppose by using a canonical transformation, a q comma p comma t, that old coordinate can change into the new coordinate, that is capital Q comma capital P comma t, while so with the new Hamiltonian, that is a transformed Hamiltonian. You have to take here, so Hamiltonian is H, you have to consider here. That transformed Hamiltonian you have to consider as a K. The transformed Hamiltonian, so you have to take it as a K is equal to 0. So with the transformed Hamiltonian K is equal to 0, you have to take that coordinates capital Q comma capital QA comma T. Suppose you know that what are the Hamilton's equations? The Hamilton's equations for a transformed Hamiltonians, the Hamilton's equations, the Hamilton's equations, the Hamilton's equations for transformed Hamiltonian. Which Hamiltonian? Transformed Hamiltonian. The Hamilton's equations for transformed Hamiltonian. The Hamilton's equations for transformed Hamiltonian is which one we have to write? Qi dot is equal to dou pi, so dou k is divided by, so Qi dot is equal to dou k is divided by dou pi, going to take it as a 0. So pi dot is equal to capital Pi dot is equal to dou k by, so minus dou k by dou qi, which is also going to equal to 0. So therefore what we have to write here, capital Qi comma capital Pi, both here position and momentum coordinates are cyclic coordinates. They which coordinates here? So these two coordinates, position and momentum coordinates, are cyclic coordinates under the transformed Hamiltonian. Under the transformed Hamiltonian, so cyclic coordinates are capital Qi comma capital Pi. That what is the Legendre transformation? By using a Legendre transformation, what is the transformation? Legendre transformation. By the Legendre transformation, already I gave what are the Legendre transformations I gave to you. The transformed Hamiltonian K is equal to, so the whole Hamiltonian H plus, you have to take it as a any generating function. That generating function dou f by dou t, you have to write it is. But the transformed Hamiltonian we have to consider as a 0. 0 is equal to h plus dou f by dou t. H plus dou f by dou t. Clear? So, but you know that f you have to consider as a generating function. That generating function you have to consider. Which generating function you have to consider? Generating function 2 you have to consider. Why you have to consider the generating function? 2 is equal to q comma capital P comma t, generating function of f2. But small p is equal to, what is that? The small p is equal to dou f2 is divided by dou t. Dou f2 is divided by dou t. Small p is equal to dou f2 is divided by dou t. So this is the generating, by using the generating function we have to write. But you know your Hamiltonian is q comma p comma t. Your Hamiltonian is q comma p comma t. So therefore your Hamiltonian is now become q comma. So what is your p? Your p is equal to dou f2 by dou t comma t. Dou f2 by dou t comma t. This is the old coordinate of the Hamiltonian. Old coordinate of the Hamiltonian. So your f you have to take it as a dou f2 by dou t. So this f2 generating function you able to consider as a Hamilton's principal function. Which one it is? Hamilton's principal function. You have to take this one. That f2 you are going to take it as a Hamilton's principal function. Then what we have to write? You apply transformation is equal to h plus dou f2 by dou t. So but here f2 is equal to 0 is equal to h of which one we have to take. So this is the old coordinate plus dou f2 by dou t. Correct? So f2 you have to consider as a, yes, you have to consider here p is equal to small pi is equal to dou f2 by so dou t, which is which one we have to take it as dou s by dou t you have to write. Therefore our expression can become 0 is equal to h in terms of what? H is in terms of q's, that is q1 comma q2 comma and qn comma. So now you able to take dou s is divided by dou 1. So dou s1 is divided by dou t. So comma dou s2 is divided by dou t comma dou sn is divided by dou t comma t. This is the Hamiltonian function plus dou s by dou t, which is equal to 0. This expression we call it as a, which expression it is? It as a Hamilton Jacobi equation. So that equation you have to see here. So though you have to take it as a not, sorry, you have to take here, you have to consider not t, you have to take it as a, yeah, p is equal to q you have to write. So this is the q suffix I, sorry, q suffix I you have to take. So that is the q suffix I. So not here s not changing, here which one is changing? Dou s by dou q1, dou s by dou q2 dou s by dou qn comma t, and t it will come. So that is the generating function you able to write. So sorry, you have to take it as small p is equal to dou f2 by dou qi. Clear? So this expression we call it as a, which expression it is? It is the expression of Hamilton-Jacobi equation. Now once you have to see the answer, Hamilton-Jacobi equation answer, option A is correct. So h of qk plus comma dou s by dou qk comma t plus dou s by dou t is equal to 0. This equation we call it as a Hamilton-Jacobi equation. Clear? Like this you able to do in your competitive examination. Once again, I am appealing to you. If you really likes my teaching, if you really inject our subject into your brain, you take this course, CSIR and GATE physics course, JL, DL physics content is available. Our number is 9908437460. My institute name is Quantum Online Academy. You download the app from your Android mobile phone. You see the courses will display like this. Once you check the courses, you check the content also, you contact with me, and then negotiate with me. You have to take the course. Two papers successfully we completed. One is mathematical methods of physics. All the topics I told in our YouTube also, right? So the second one is classical mechanics. All the topics I told in classical mechanics in our YouTube also. Now we started the electromagnetic theory. Which paper we are starting? Electromagnetic theory we are starting. Every day 6 a.m. to 8 a.m. their must class is going on in our app. Every day in between 6 a.m. to 8 a.m. there is a class is there. So this class you have to join. Live plus recorded classes are going on electromagnetic theory. So tomorrow onwards in YouTube, I have to start the discussions in electromagnetic theory also. Thank you so much. Please share and subscribe and inform to your friends and encourage our YouTube channel. Thank you so much.